Why is RNN training difficult to parallelize sequentially? Imagine trying to read a story where each sentence depends on the one before it. Now, think about teaching a computer to do the same. That's what makes training recurrent neural networks tricky. These networks process data one step at a time, where each step depends on the previous one. When training, the output at each point relies on the hidden state from the previous step. This creates a chain of dependencies that can't be broken easily. During the forward pass, the network calculates the hidden state at each time step based on the previous hidden state and the current input. This means it has to finish one step before starting the next. If it tried to do multiple steps at once, it would lose the connection between steps. The same problem happens during backpropagation, which is how the network learns. Gradients, or signals that tell the network how to improve, depend on future steps. So, the calculations for earlier steps can't be done until the later ones are complete. Another issue is that training RNS requires storing all the intermediate states from each step. This takes up a lot of memory and makes it harder to split the work across multiple processors or computers. While some parts of the process, like matrix operations within each step, can be parallelized, the core sequence of steps can't. This is different from models like transformers, which process all inputs at once and are much easier to train in parallel. Because of these dependencies, training RNS tends to be slower. It can take more time to train a model on a large dataset because each step has to wait for the previous one. This makes scaling up more challenging compared to architectures that can process data in parallel. In real-world applications like language modeling or sequence generation, this means training can take longer than with newer models. Researchers are working on ways to improve this, such as using special algorithms or alternative models that can handle parallel processing better. In the world of artificial intelligence tools, this is why models like ChatGPT, which use transformer architectures, are more efficient to train. They process data all at once, saving time and resources. Image generation models like DALL-E and Midjourney also use architectures that allow for faster training because they don't rely on the same sequential steps as RNS. So, the main reason RNN training is hard to parallelize is because each step depends on the previous one. This creates a chain of calculations that must be done in order, limiting how much you can do at the same time. It's a fundamental challenge that affects how quickly and efficiently these models can be trained.